I can't actually tell. Awesome. Okay. Welcome, everyone. This is the SIG Auth intro and deep dive for KubeCon North America. What is this, 2019? Yeah, good. So I want to let everyone know this is super informal. As a show of hands, who here in the audience has attended a SIG Auth meeting before? Okay, so basically we have like a little agenda and anyone can join at any time on Zoom and we just talk about stuff and anyone can get right access to our agenda and all those things. So in that same vein, if you want to ask a question at any point, just say it, raise your hand in any form.
We'll bring the mic over and speak in the mic on the recording.
Cool.
And also, I'm Mike Nice.
Oh yeah.
My friend Mo. This is Tim, and we're the current chairs of SIG Auth.
Yep. Awesome. So, did someone ask something? No. Okay. So, there's a decent amount of us. I won't necessarily go over the names. So, Mike and Tim and I have been introduced. We have a bunch of sub-projects which sort of get managed by a set of different people, not necessarily us. That list of reviewers is not complete by any means, and you don't, for example, have to be a reviewer to review our code. It's more of just the set of people that are sort of guaranteed to get pinged by the bots. If you've ever tried to make a PR to the Kubernetes repo, the bots just show up and harass you immediately. So, of course, you have to have an Xkcd comic. We're the one that try to stop you from connecting and talking to all the things, or at least not unless you have MTLS or something. But so the SIG Auth charter is effectively centered around protecting access to Kubernetes components, authentication and authorization being core tenets of that. We do have some level of ownership of things like auditing and some set of security policies. We generally don't have ownership of things like network policy, though. Even granted, some people consider that security as well. So there's a list of sub-projects, auditing, both forms of auth, certs. Mike loves certs, so he can always talk to you about certs. If you are familiar with the KMS API or just the encryption config in general, encryption at rest is an important piece of that. Multi-tenancy is still sort of in its relative infancy for Kubernetes as a whole, but we are making progress. If you're familiar with the node authorizer or the node admission plugins or restriction plugins, those sort of encompass node identity and isolation. We're going to be discussing some policy stuff later today, and if you've ever used a pod, you have at some point used a service account, whether you know it or not.
And I also think what is not on this list is interesting. We're not a SIG security. We handle supposedly identity and authorization, but we sometimes take on things like encryption at rest where there isn't another good fit. But we don't handle security for the project. Security is everybody's responsibility. So for node security, that's something that SIG node would handle. We don't have a general security SIG in Kubernetes.
Yeah, and in general, if there was a CVE, we're not the mailing list that you email to report the CVE.
Yeah, that's the
that's product security. CJ is right there. He says he loves product security. You can just give it all to him and Tim.
And Tim, yeah.
I'm not saying this slide. It's all you, Tim.
Oh, all right. Yeah, this was kind of supposed to be our theme for.
Let me move.
This is kind of supposed to be our theme for 2019, but we still have a lot more work to do, so this is kind of our theme for 2022. 2020 also.
Yes.
Yes. And so what we mean by that really is paying down a lot of tech debt that we've kind of accumulated. We have a lot of features in alpha, beta, and kind of legacy states. So the first thing we want to do is get things that are in alpha beta state to GA. So here's a list of some of the things we have right now. Certificate rotation for kubelet certificates. Mike, you were going to add...
The certificates API in general.
Yeah.
tokens, we have a lot of material on it later, but these things often get to beta, and the people driving them sometimes disappear, and we need to either...
So as a question, who all in the audience is familiar with like feature states like alpha, beta, and GA, and sort of what they mean to the Kubernetes project as a whole? Okay, so most of you guys have a decent idea, but the important bit about beta is a lot of providers will enable the feature by default, and has this perverse incentive on developers to get a feature to beta and then ignore it.
Yeah.
And we are somewhat guilty of that. We just got busy in various places.
But
yeah, so there's ongoing efforts from SIG Architecture and other related groups to sort of make it harder to leave something indefinitely in beta, if only so that like production clusters must not rely on beta APIs to be like functional. So.
And then we're going to be talking about pod security policy in a lot more detail later in this talk or conversation. And then dynamic auditing is a feature in an alpha state that was added about a year ago and hasn't progressed a whole lot. And so I expect we'll have some more conversations around what the future of dynamic auditing is going to look like. But it's an open question, I would say. And then we also want to deprecate some things and delete some code. ABAC, did we actually decide to deprecate ABAC?
Jordan refuses to let me deprecate it. I'll keep trying.
All right,
As a quick thing, does anybody in this audience use ABAC? Like, anybody?
Yeah, we should deprecate.
Does anybody not know if they're using ABAC?
That's, I guess, a possibility. See, nobody uses the thing. Just won't let me delete it.
Yeah, there's a bunch of admission controllers that are not turned on by default and are already marked as deprecated. Or maybe those ones aren't, but we should be. And then there's some that are marked as deprecated, and we want to delete them. So a lot of cleanup. We are still open to new features, but a big focus is going to be kind of stabilizing, adding better test coverage for these things also.
Yep.
Who wants to talk about highlights?
Mike, you did all those retroactive caps. Oh, not the middle one.
Okay, so along the lines of that cleanup, we added a bunch of retroactive caps for some of those beta features. So to give background, for example, that first one, that API has existed since Kubernetes 1.6. It's about probably over 3.5 years old now. It's still a beta API. We have a lot of things that we don't really like about the shape of it, but it's beta and it is used extremely broadly among Kubernetes deployments, and it's a pretty critical API. In order to make progress on this, we created a KEP that describes the existing state. Since I think the original PR was in the PR 8000 or something. This was long before we had a formal process for introducing these features. So what we're going to do with this KEP is we're going to use it as a place to initially write down some user stories, which is not something that we had considered when we implemented this API. So we want to really understand how we want people to use it, and then from there, we can start to discuss graduation requirements and basically a checklist of things that need to happen before we mark the API as GA. Similar story for bound service account tokens. That was slightly predated the Kubernetes enhancement proposals. So David Eads did a bunch of work on basically making every single certificate bundle that we read from in Kubernetes dynamically rotatable. There's a really old issue about how difficult it is to rotate the service count CA cert. I think it's like Eric Toon's issue in the 5000s. I think we've gotten through basically all of the certificates. now that they're reloading, except for I think there's one left to do. And once we do that, we'll have a lot better story for automated rotation of certs in the cluster. Do you want to do the kubelet one? Do you have context on that?
Yeah. We've restricted the labels that kubelet can add to itself. This is sort of a multi-release rollout process. I think we finish it in 1.18. So we're also adding some more restrictions on what the kubelet can do to run it as even more least privilege, because there's actually a lot of things the kubelet can do. A lot of ways it can escalate privilege if we're not careful. But also it turns out that if you have owned the node, that you're in trouble in a lot of other ways. We talked about this.
Yeah.
I gave a talk on this earlier. Go back and watch it if you haven't. So we'll probably continue to build out node restriction, but it's not going to be a big focus area for us, I would say.
And so are any of you familiar with the priority and fairness KEP from API Machinery? They're working on building some support for API priority so that you can't have a disruptive controller overwhelming the API and destabilizing the cluster. That feature is going to, I guess the fairness is keyed off of the identity of the caller. So in order for that to be a viable approach to implementing priority and fairness, we actually have to make authentication a lot faster than it is today. We've, in the past, probably 3 releases, there's been maybe 6 or 7 major improvements to the performance of authentication. So we're gonna, we have, I think, 1 more open to improve it further, but we want to make sure that we are able to meet the requirements of the priority and fairness KEP. And then,
I was going to say a bit of context on that KEP. Like, if you, in the current state of the world, right, we basically rely on clients being nice, right? And it turns out that it's not good DOS protection.
yeah.
So.
And finally, this is, we're getting, we GA'd admission webhooks. This isn't necessarily a SIG Auth feature, although a lot of people are using this as an extension point to build expressive policy engines, or to hook in policy engines. For example, Gatekeeper and OPA. And is there anybody else using it yet?
There was someone else who had mentioned, it starts with like a K, I can't remember the name of their project, but it's
Webhook admission plugins?
Yeah, that, like they have their own thing that's kind of like OPA.
There's a lot of projects using webhook admission.
Cool.
So to everyone who said that you hadn't been to a SIG Auth meeting before, you should come to a SIG Auth meeting. You can do so from anywhere with a laptop.
And internet.
The SIG Auth code can be a little gnarly to get started on sometimes. It can be pretty sensitive to subtle behaviors. But we try and tag issues with good first issue. If you aren't super familiar with the code base, that's a good place to get started. Or for more experienced contributors who want to help out, the help wanted labels are for that purpose.
If I could do a shameless plug, my deep dive in Barcelona was a walkthrough of some of the code. I'm not going to say it's going to make it that much easier, but it'll probably make it a little bit easier.
I'd say as kind of a general piece of advice for getting involved, we're always looking to improve our test coverage and better document our features. Yeah.
And for anybody who came late, we're open to questions during the entire talk. So cool. I think that concludes. Is that the last slide for the intro? Oh.
This is how you can come to our meetings.
Yeah. I think the next one.
And if you join the mailing list, anyone can add, that gives you write access to our agenda document. So if there's a topic that you'd like to discuss at SIG Auth, you can just add it to the agenda. And assuming there's time, we'll fit it in and discuss that. Any questions so far?
All right. Now the fun stuff begins.
All right, let's do it. Okay, so I'll start this topic by asking a question. Who here in the audience knows what RBAC is and has used RBAC?
Good.
Awesome, I like you guys. Let's keep doing this.
One more question. Who filled out the poll that we sent out to ask about what we should talk about today? Did anybody fill out the poll? We got a lot of responses.
Yeah, it was surprising.
But then I guess nobody showed up. So there was a group of people that are not here today that select these topics for you.
Okay, so who here knows what pod security policy is? Okay, who has enjoyed using it? You don't have to answer that. That's okay. Okay. So it is a built-in policy API. It is sort of like RBAC for pods and instead of users. It's distinct in the sense that most of auth works on a very well understood set of bounded things. And when I say auth in this case, I mean what RBAC can address. So RBAC has no concept of label-based auth. RBAC can't even do deny-based auth. So the general question would be, or the simplest question is, can you run a pod as privileged, as for example? That's sort of what PSP exists to protect against, which is an administrator may want to make it so that you can't just run root privileged pods everywhere and sort of kind of defeat the point of having containers in the first place. So I already mentioned the root bit. It does have some interesting aspects in the sense that theoretically, the person who is writing the code and the person who is managing the cluster are not the same individual. And in this case, the cluster admin could try to enforce a set of best practices on the workloads that are running. And it may be that the developer who is writing the web app or whatever does not have the security expertise to do that work, and the cluster admin or the IT operations folks can do it better. So I don't know when PSPs were added. Do you guys remember the release number?
1.3, I think.
Okay,
Maybe
so
1.2.
a long time ago. So for the history of that, in the very first release of Openshift, security context constraints were there. And to give you some sense of it, that is before Kubernetes 1.0, right? So no one had ever run a production cluster, right? So
That's not true.
What?
That's not true.
Oh, okay, fine. No one should have run a production cluster.
That is true.
Yeah, right. So what SECs were trying to solve was not a well-understood problem. We'll gloss over if it's well understood right now or not. But so PSPs were sort of based off of that. But they're significantly stripped down or altered in certain ways. But both the translation from OpenShift into upstream Kubernetes and the fact that both were built without necessarily a fine understanding of what problems we would encounter in this space sort of has led to a weird shape to everything on this. So first of all, this basically gets everyone, please tell me you can't see that. Oh, good. My wife is text messaging me and it's showing up on my screen. Sorry. First of all, generally speaking, when people start using Kubernetes, they want to go run a pod because that's the first thing you do. And I guess in an attempt to address that use case, it was sort of built out that if you're cluster admin, well, obviously you can do anything. So PSPs allow basically the user who is making the request to authorize the pod or the service account that the pod is running as to authorize the pod, right? And this sort of makes sense until you realize that no one is actually supposed to directly run pods, right? In any realistic scenario, you use a deployment, which runs replica sets, which runs pods. So you get into this weird mode where you yourself might have granted, like, you might have had the permission, but then you try to run a deployment and it fails because you didn't grant it to the service account. Or worse, you have decided to grant cluster admin to all the controllers that run the main control plane, and you don't realize that that has, in fact, caused it so that all pods in your cluster can run privileged, right? There's another weird thing, too, in that we use RBAC to sort of, or we use authentication/authorization to do this using the use, like it's a virtual verb. Effectively, you ask, can you use this PSP? But you can bind that to like a namespace level with RBAC. But if you bind like a privilege granting PSP in a namespace, there's nothing keeping it inside that namespace as a pod, in the sense that you could hurt other pods running on that node in some other namespace, right? So like you can think you've bound it to some place, but you haven't, right? So like it's completely unclear, right? Another aspect is that when you roll this out, you get to roll it out all at once. This was never an issue in Openshift because there was no release where SCCs weren't enabled by default with some policy. Now, to be fair, in the early days of that caused a lot of pain for Openshift customers because they couldn't figure out how to run pods. It's very strange having an orchestration platform that can't orchestrate pods. It was painful. But imagine, you've been using a cluster for some amount of time and it's working fine, you have workloads running and you're happy with it, and now you decide that like security is important, you actually have important things running on it and you want to turn this thing on, right? You have to, in one fell swoop, audit every single workload, understand all of their requirements, and create policies that sort of match all of them in one go, right? If you turn it on and you have no policies, all pods will get rejected and nothing will work anymore. And unlike SE Linux, which you can, at least have in some kind of permissive auditing mode, PSP has no such functionality. Another little bit is, unlike SEC, PSP doesn't have a built-in policy, and in the sense of a bootstrap policy. And I think that was initially just there because we didn't know what anyone needed, and it didn't sort of make sense to just take the guesses we made in Openshift and put them out into the world as canonical things. But unlike RBAC, if you sort of see RBAC being used in like Helm charts and other places, they tend to include like manifests, like nice, complete manifests of what can a workload do. That sort of culture doesn't exist for PSPs. And sort of the byproduct of all of this sort of organic growth is basically, it's just hard to use, right? There's no like real well thought out design. Of all the things, I think this one, like with a lot of concerted effort, could be fixed, but it's sort of hard to justify at certain points. The composability bit is also interesting. Like if you think about RBAC, you can grant something 2 permissions and it can do either one of those actions then, right? You can't assign a pod 2 policies and have it sort of have the union of those policies. A single policy has to authorize the entire pod. And in a similar way, if you have 2 policies that do apply to a pod, there's no good way to prioritize. It just goes alphabetically. So if you have a pod that could, for example, run with no permissions, but privileged is in front of restricted, it'll run privileged. It's great. So if you have used PSPs before, we would love to sort of hear feedback. We had someone from, yes? Go ahead.
So one of the problems we've seen with pod security policies is, yes, the lack of having a pod security policy, but also the lack of a lot of public charts having actual security context on the pod definitions themselves. So really, we can't expect them to implement pod security policies when they haven't even put the security context for their containers themselves. So do they run as root? Do they not run as root?
Right.
None of that other stuff is populated ahead of time. So even as like a community, it's harder to say, here's a pull request to add a pod security policy.
Right, and I think that's a byproduct of like when when RBAC went like V1 GA, right? Like we didn't. It didn't mean that somehow we could immediately have it like as the only form of solution, right? But over time, it has matured, and the community has decided that they like it enough to include that in their manifest, right? I don't think PSP ever got anywhere near that level of like critical mass to cause sort of a pressure on like people who develop Helm charts to like actually worry about that. Mike, did you have something?
Yeah, even so, RBAC is still not enabled by default, but it is like de facto to the point where people do think about it, and we should figure out how to do something for PSP. Or I don't know, Tim probably has
There's
some
two
thoughts.
questions in the back. As you're walking there, so just to give you everyone in context, right? We had someone from Twitter come in on our one of our weekly meetings, and that was probably one of the first time we've had like concrete feedback from someone running like a lot of pods in like big production clusters for how they use PSP. And if you do that, please tell us how you do it and what works and what doesn't, because like it's very hard for us to make like forward movement in this, but like just looking inwardly, right? Like Google, VMware, Red Hat, like we're very big corporations with very big IT budgets, and we can basically kind of do whatever, but that doesn't necessarily scale to everyone else.
We do run PSPs in our clusters. The general thing for Kube system, we have a privileged one because you need it. And for everything else, for system authenticated group, we have a restricted policy, which is for every workload out there. Now, I share the same same pain that he shared about like Helm charts not shipping PSPs with them by default. But then there is also another way of looking at it, like not everyone who is installing charts on the cluster has permissions to install PSP, and you definitely need a cluster role to be created to use the PSP. So that's one other problem we have here. And since we allow it, like we allow the system authenticated, like since it's called restricted, and then sometimes we create a PSP which is catered to that particular workload. But then since two PSPs are now applying to that particular workload, this alphabetical thing comes into picture, and then it works very weird. Sometimes it picks up, sometimes it doesn't, because your API server is still reconciling that you have fed the PSP, but meanwhile the pod is already coming up. It picks up the restricted one and not the one that it was catered to. So there is always, you have to like go back and check whether it has picked up the PSP it was tailored made, or it has picked up the restricted one. So you have these problems as well.
I think one place where we sometimes run into confusion around pod security policy is that the distinction between pod security policy and pod security context. And so pod security context is saying, what is this pod actually going to run with? And pod security policy is sort of, if you think of it as who can create pods in that namespace, what is the maximum privilege that I'm willing to give them on those pods? And so we can kind of think of that as like, pod security policy sort of defines the upper bound, but the pod security context is what should actually be saying what security the pod is running with. I think the API slide kind of touched on this. There's a lot of, there's some debate around mutating pod security policies and whether mutation on these policies is actually something that we should have at all.
So I guess maybe I do have another question, but I just want to say, so do you think it'd be fair to say that you could think of like the pod spec, including the security context, as like, that's the key, and then the PSP is like the lock that if the key don't fit the lock, then it won't turn?
Yeah, that metaphor works.
Yeah, cool.
I think
Okay,
you
good.
could also say like, you could say that the security context is the enforcement point, and it's kind of like the security context is actually the policy for the runtime, the actual running pod. That's like your data plane policy almost. And then the pod security policy is kind of like a meta policy on top of that. But that probably just is more confusing.
That's why I picked a metaphor. Yeah, the question I had was about, I've actually, I used to work at a company where we used PSPs really heavily. We actually ran a cluster that was a completely untrusted workloads where people could schedule any Docker container they like and run it. And because of things that I had no control over, those pods had to run as privileged because they were running Docker and Docker. As you can imagine, it was pretty nightmarish from a security context. So we tried to do everything we could around it, but obviously we tried PSPs a lot as well. And so I was pretty familiar with them. And then I moved to a new job, and in my new job, I am releasing an ingress controller. And we recently had an issue where someone was like, "Hey, could you please include a PSP with the thing?" And I'm like, "Well, that actually sounds like a pretty good idea." Until I started thinking about what happens when, what happens if I supply this as part of our default manifest and someone has PSPs like not enabled, or someone has PSPs enabled and they've configured like conflicting ones, and then we override them as part of our default manifest. Again, it comes back to the same issues, but like that might also be another reason why people aren't including this, is because as soon as you go to try, you end up in this sort of thicket of really woolly questions about like, what am I actually trying to achieve by doing this, and is it actually going to increase people's security or not? Yeah, I don't know. It turned out not to really a question. Sorry, but like my question was more so like, do you guys have any help that you could give me there, right? Like this is the actual question. Sorry.
No problem. Thank you.
I think actually the next slide is sort of the help.
Okay.
So let's go to that.
Let's do it. So, and I promise the second question we were asked was not like a plant, because it sounds almost exactly like what the slide is suggesting, which is basically that from what we gather from the conversation with the folks from Twitter, and just in general of how we think about most of these, we could probably define 3 buckets for workloads on a cluster and cover most of the common use cases. So the obvious one is privileged, right? You just your root and do whatever you want, right? And then there's the restricted state, which is basically what every security person wants you to do, which is you're not running as root, you're not running in the privileged container, you've dropped all caps, you only have a small select of volumes that you can mount, like no host path, no host network, none of that, right?
Add the default seccomp profile.
Oh yeah. All the things, right? Like your IT admin is very happy because the worst you can do is destroy yourself. Yeah. And then there's sort of default, which is sort of more of, it's similar to restricted, but basically not necessarily not as tight and more based on, what did you say? You had framed it as
if you hit next.
Oh yeah. Okay.
So this is like the absolute bare minimum pod you could spec. The pod has a name, it has one container, the container has a name, and it has an image. Like this is the minimum you can specify. The goal of the default profile is that you can do this. The default profile will allow this pod. If you try and escalate privileges above what this pod is allowed to do, then it will get denied. And so ideally, we'd just have the privileged and restricted buckets, but to actually kind of cover the majority of use cases, this default one will help us there. So this is sort of our hypothesis. We've got some evidence. The engineer from Twitter said they were doing something similar. I think someone shared some information that Openshift has seen similar usage.
Clayton. Yeah, it's interesting to see that you have this relatively flexible policy, but the reason that the Twitter folks decided not to go crazy with it is they found the management of the policies to be too difficult. So for them, it was just easier to have like a contract with the developers that they won't break the cluster than to try to come up with bespoke policies per workload. And I think it's a very interesting point, right? it sort of tells us that we don't necessarily have to support every little use case because most people can't even manage the use cases that way.
And going back to your question of what do we recommend for if you're deploying a thing, how do you include a policy with it? I would say ideally, you shouldn't have to because it should fall into one of these buckets. And we can say, as the cluster administrator, you've bound these buckets in the correct way. We're not there today. And we'll be talking a little bit about the future of how we plan on fixing this. But Mike.
Sure.
I guess the main value add that I was actually looking to add was to be like, for me to be able to use the pod security policy as de facto documentation of the permissions that we know, like the least privileges that we are confident that the app will actually need, and sort of say, maybe if your privilege, if your restricted thing doesn't look kind of like this, then it may not work, or something like that. I don't know.
Yeah, so I think that gets back to that earlier point of defining the security context on the thing that you're deploying so that it's using least privileges. And then it's sort of self-documenting. Yeah, yeah. And we've talked about, we have a few ideas, which maybe we'll go into in a little bit, around what to do with these three buckets. One of the ideas is just to kind of publish this as official Kubernetes documentation, that we think these are the buckets and these are the permissions we think should go in each one. And then if we had that, then an app could publish as part of its documentation, we run in the restricted bucket or we run in the default bucket.
That has a nice property in that we have added stuff to security context over time. For example, like Windows containers, new types of sandboxes, new additions, no new privs. We need to be able to keep, I guess, each of those buckets is like an ideal, and adding more restrictions to a bucket means that we could potentially break applications. So potentially by moving this into documentation and having users curate it to their needs, we could avoid that problem.
Yeah, privilege should never change. You can always do everything.
Yeah.
Restricted, we expect to change over time. And so that would probably need to be versioned. So this is a restricted profile as of this Kubernetes version. As we add features that kind of further protect pods, for example, stacking Linux security modules is coming, so you can attach, maybe someday you'll be able to attach an AppArmor profile in your container that layers on top of the default system AppArmor profile, or layer SE Linux and AppArmor together. So that's as an example of something that might come. User namespaces is another one. And so as we roll those things out, the best practices are going to change. And so we would want to be able to say, like, the next restricted version. Default may or may not need to be versioned. I'd need to think about that a little harder.
Any questions or comments or thoughts on this?
The only use case I can think of off the top of my head is the one where you would want to give access to the host node file system, but only as read-only for like virus scanning or other things that check the compliance of the host system, but you don't want to give that particular pod access to modify those files.
So storage, there's now a local persistent volume, which is sort of the administrator-defined host path volume. And so a privileged user can say, I'm going to define this local volume or this local view of the file system, and then make that available to less privileged users through a persistent volume claim to use in a pod. I don't know offhand if you can say that this local volume is read-only, but that might be an interesting way to tackle that problem. Yeah, I guess you can do that in PSP today through the read-only host mounts.
That's how you bypass
Yeah.
So we've sort of been discussing this a little bit, right? So how do we go from today to where we want to be? Okay? So sort of the obvious thing would be fix PSPs, right? It's not necessarily clear what that means, but it sort of has to have some vague concept of being on by default. It almost certainly then thus needs like an audit mode, because that's probably the best it could be on as a default thing, right? Like, I would be rejecting all of your pods, but I'm not. There's still other bits and pieces of it, like as we've sort of talked about, that kind of are still unclear, right? So we could also decide that PSP isn't working and we need to build something else completely different, right? So we talked about sort of like the 3 buckets, right? We were framing it in the context of like in-tree, but I think that is one of the bigger questions that we're trying to understand, right? Which is, does that have to be the case, right? Must there be a built-in mechanism for pod policy, right? And I don't think necessarily like the SIG can answer this question by itself, because it's more about sort of like how people imagine using the platform, right? Like I as a user of the platform would kind of be bothered if like RBAC was like not part of Core Kube, just because I'm so used to using it, right? One of the suggestions to sort of take PSPs back to its roots was to convert it into a webhook that was actually backed by SCCs. So like Openshift security context constraints can still do basically everything that PSPs can do. So if you guys are familiar with the history of RBAC, it started out in Openshift as authorization policy. It was upstreamed as the RBAC API, and then once we had gotten to the point that RBAC was sort of done, in Openshift we built controllers to basically take the authorization policy data live, convert it into RBAC, and keep them in sync. And then a release later, we flipped it and made RBAC the source of truth instead of authorization policy. We had a proof of concept of this in Openshift to do the same thing. That would sort of make things better because SCCs have worked a little bit better than PSPs in Openshift for a few years, but I'm not sure if that necessarily gets us to an end state that we're happy with. But those are just sort of suggestions. And I think one of the sort of suggestions is to use OPA. So I'll let Tim talk about that.
All right. Yes, this is, just to kind of frame this conversation, this is one of the, I would say it's one of the leading proposals for the future of pod security policy. Would be to basically say, we're going to deprecate pod security policy, and we're going to build a really good migration path to the Gatekeeper project, and sort of encourage that as the de facto standard for limiting pod permissions. And of course, you can run any admission policy you want, but this would be sort of the kind of the standard direction that we point people in. So that's just kind of to frame this discussion. Now let's talk a bit more about what OPA and Gatekeeper are. Before we go into that, can I have a show of hands? Who has heard of OPA or Open Policy? All right, let's see. Who has actually used OPA? All right. And how about Gatekeeper? Who has heard of Gatekeeper? Pretty good. And who has used Gatekeeper? Nobody. OK. It's a new project, so. What is it? So this is Rego. This is, I just pulled this out of one of the Gatekeeper templates. It's cut off at the bottom because it didn't fit on the slide. I don't actually expect you to read this, but the point is there's a lot of work to express a fairly simple policy that says a container must run as a user. You could probably do this in fewer lines of code if you're just writing a straight up OPA policy for this. This is a bit more generalized and flexible to fit into the Gatekeeper framework. But the point is that not everyone here knows Rego. Probably everyone here is comfortable using YAML or JSON. And so what Gatekeeper tries to do is let's simplify that for the people who don't need to worry about it and just templatize that code that you just saw. And so then the users of this policy can just provide the template parameters for that policy. And so the two key pieces of this constraint, which is how Gatekeeper expresses the policy. A constraint is a type of policy, I guess. And then this is an instance of the Kate's PSP allowed users constraint. And so this is saying that we want to apply this constraint to pods. You can also match on namespaces and labels and a bunch of other things. And then we also parameterize it. So in this case, we're saying we must run as root in this user range. So it should look familiar if you're used to PSPs. And one question this raises is if you're already defining these things through CRDs and writing some code behind it, like why not just use CRDs and custom webhook admission controllers? And that's a good question. One answer is that it simplifies it. So you don't need to write as much boilerplate to add a new policy type in through Gatekeeper. You just need to write some Rego and put it in this constraint. I think it's called a constraint template definition. Yeah? Max tells me yes. The Gatekeeper team is here, by the way, to tell me when I say something wrong. Yeah, so that's one reason you might use it. But I think the much better reason why you would use this over custom admission is that if you use custom admission controllers, that is only valid in an API server. So I need to actually go and apply my manifest to an API server. And they're adding dry run, or I think we have dry run today, so you can sort of see what would happen in the API server, but still that doesn't necessarily fit into the context of a GitOps workflow or like a pre-submit check or something like that. Whereas with Gatekeeper, you can actually apply this at anywhere in your pipeline. And so it doesn't need to be just when you're actually creating the object in the API. You can also apply it to your code in your CI/CD flow or anywhere else. And actually, if you kind of by similar logic, you don't need to just use this in the context of Kubernetes. You can then have consistent policy not only in Kubernetes, but also for your declarative infrastructure and even your data plane policies as well. So kind of unifying all of the policy in one way that can easily be audited and understood together. So now I've just shamelessly copied slides directly from the Gatekeeper team. And you can see the nice little styling has changed to reflect that. So these are the current core features of Gatekeeper. We have validating admission control, context-aware referential policies, which I think means that constraints can reference objects that you're not just applying the constraint to. So for instance, you might want to say, check if a namespace has if a pod's namespace has a label. And you can't just do that if you're only looking at the pod. You have to also say, well, this pod references this namespace. Let me go look up that namespace and check the label on that namespace. We already talked about parameterization and templates. And then we also have an audit mode. Maybe someone from the Gatekeeper team can explain audit. Max, why don't you introduce yourself?
Hi, yes, my name is Max Smythe. I'm one of the maintainers of the Gatekeeper project, along with Rita.
Hi, I'm Rita.
And yeah, I think one of the uses for audit that I heard from a question here, someone was mentioning they had there's some almost like a race condition with PSP where a pod got started, but under what auspices did it get approved, right? The old PSP, the new PSP, right? And because not only is Kubernetes like an eventually consistent kind of model, but also your policies change over time, you run the risk of drift, right? Like suddenly you add a new policy and something that is currently running should have been disallowed. So audit is a great way to detect that kind of situation. It's also, I would say, one of the other benefits of dry run is that when you have something pre-existing in the cluster that is non-conformant, dry run violations show up in this audit result process, kind of like as its own category. So you would know that you would be breaking pre-existing things in the cluster when you start enforcing. So it's more of a safer switch flip.
Thanks.
Yeah.
And so the latest update project, we now have dry run. So apply it to manifests before they're actually applied. Namespace selectors let you say, I want to apply this constraint to this set of namespaces. There's a policy library. The eventual vision is to have a whole policy ecosystem where hopefully you never have to touch Rego. Someone else has already had the same problem that you're trying to solve, and they've already written a constraint template for it. And so you can just, maybe even as a Helm chart, you install this, this constraint template and then parameterize it as you need. And multi-source constraint templates let you break out the Rego source from the template, I think.
Yeah, no, so this is about sort of code reuse at the Rego level, right? So there's already a lot. OPA has some Rego libraries for some common tasks. As more people develop constraint templates, we expect that there will be more patterns that happen, like assuming a value is some default value if it doesn't exist, that kind of thing. So multi-source constraint templates, essentially you can have all of your Rego libraries embedded in the constraint itself so that you could share code without copying and pasting. It's sort of like the first step toward a authorship toolchain.
And metrics. Everyone likes metrics. And so, so that's kind of like past, present, and now we get to future. Working on productionizing the process or project. What's the current version? Beta. Okay, yeah. So yeah, get that to GA. There's open proposals for adding mutation, so not just validation, but being able to, if we actually want to get to feature parity with pod security policy, which, by the way, I'm not necessarily sure that that should be the goal, but if we want to get to feature parity with pod security policy, we need mutation there. I don't know what the next one means. Should just get you up here to.
Yeah. So external data, a common pattern that people are wondering is like, I have an LDAP database, right? Like I want to verify that not only am I referencing a user-like thing, but it's actually a user at my company, right? So when you have that kind of external system, how can we write policies that reference that, but in a performant way, right? So maybe a caching mechanism. I don't know.
All right. And then, yeah, more productionizing features. And I want to make a comment on this last one. So right now, a common way of matching or applying policy or constraints to specific objects is by matching on labels, whether those are labels on the resource itself or labels on the namespace that that resource is running in. And so an idea that I've kind of floated to a few people is maybe this is the one place where it really makes sense to build policy into Kubernetes, is to have authorization on labels. And then you can use those authorized labels to control the authorization of all the policies that apply based on those labels. So that's an open question, something to discuss later. So maybe before we move on, are there any questions on Gatekeeper or policy in general?
Or PSP?
Excellent. Yeah, good. On the authorization aspect, you do have to remember that things like OPA that run as admission controllers cannot affect non-mutating things, right? So they can't affect get, list, and watch. So RBAC can address those cases to a certain degree, but not in the same way as a mutating.
And the authorization does not have access to the body generally as well.
Yeah.
The request.
In case this wasn't made clear earlier, SIG Auth doesn't own or even work on the Gatekeeper project or OPA. And so you might be wondering kind of like, why are we talking about this so much in SIG Auth? And it's because we're exploring what the future of pod security policies are. And this is, as I mentioned earlier, kind of one of the leading contenders. There's other projects out there that are also, we're also exploring. And so we're kind of looking to get some consensus in the community to help guide the future of the policies that we do manage through SIG Auth and figure out what the right way to work together as a larger project is.
Any questions? Comments? Cool.
Could you specifically go into what would be needed for a mutation, why the mutation would be needed to reach feature parity?
Yeah, so pod security policy today has the ability to set defaults on fields. So you can say if no user is provided, then this pod should run as this user by default, for instance. There's two ways you can use that today. One is to say, well, you can run with higher privileges, but I'm going to encourage you to run with these best practices privileges. I think the more compelling use case for mutation in pod security policy is if I place a restriction that's not default, not the pod default on you. So for instance, if I want to say, you have to enable the Docker default seccomp profile, then all of your pods would break, and you have to go and change every single pod template to say, add in the Docker default seccomp profile. But with mutation, you can say, you have to run with this, and also I'm going to default it to that, so you don't have to worry about changing every pod.
The only conflict you get is something else, and if that wasn't okay, then you get an error. A even much more trivial and much more simpler case is it's nice to know what PSP your pod is running at, and does it annotate or label? I can't remember. But it mutates the pod to say you ran as this PSP, right? And that's really nice just in the sense of if you look at all the admission controllers we have today, they don't necessarily record what they did and why they did it. So just having some feedback to the user, like your pod's failing because it's running as restricted and it's just not going to work, or something along those lines.
I just have a simple question. So is there any timeline for the next version of the PSP policy?
No, so that's kind of what we're trying to figure out here, is what what does the next version look like? Is the next version just Gatekeeper and deprecate what we have today? Or do we try and fix pod security policy? That was the slide we had earlier of like, what is the path forward? We don't have an answer yet. And because we don't have an answer, we don't have a roadmap. Some people have been concerned that we've said, we're going to get rid of pod security policy. One, that's not a final decision. And two, we won't get rid of pod security policy until we have a really strong alternative and a good migration path and tooling to that policy. And then even then, it will still be a gradual deprecation policy or process over, I don't know, probably around a year.
Yeah, so I mean, if we wanted to put like some numbers on it, let's pretend in 1.18, the entire SIG did nothing but this, and we somehow managed to do all of the work in one release. That would mean we deprecate PSPs in 1.18, and then at a bare minimum, probably in like 1.21, we remove them. Right? So that is like, it would be insanity. There's no way.
I would guess that we're gonna figure out this roadmap and figure out what the next steps are in 2020, and probably deprecate and remove PSP by the end of 2021 would be a guess.
Any more questions? Awesome. So now we're going to talk about something entirely different. This was another thing that polled well. Does anybody know what bound service account tokens are? Or I've heard that word. Okay, so does anybody know what a service account is in Kubernetes? Hopefully everybody. Service accounts, since before 1.0, they have a feature where we have a controller that generates a token, shoves that in a secret along with the CA cert of the cluster, usually, but not always. And we just plumb that down to every single pod. In the client libraries for, in the client libraries for client Go and actually most others, there's a zero config client functionality called in-cluster config. You call that function, you get a kube client, you can talk to the kube API server as the service account that the pod is running as. There's some downsides to that old architecture. A couple big things are those tokens are stored in Xkcd. They never expire. They're extremely difficult to rotate because you basically have to delete the token secret, make sure that the token controller regenerates it, do a rolling update of all your pods, try to make sure that all these things line up. I think there's like somewhere in the documentation, it's not even in the documentation, it's in an issue somewhere, there's an 8-step process on how to actually rotate service account, service account signing keys. And the third thing is, on this list is, there was no audience binding. So we originally intended these tokens to be used only against the Kubernetes API server. That was the whole reason for adding them. We never documented that they were of any structure. However, they are JOTs. So if you wanted to, you could look into them and see what service account it is and validate them yourself using the signing key or the verification key of the service account issuer. And that's what people did. So they took that token and they started handing it to Vault and other things to build cool features. However, it's not particularly good practice to be handing these broadly scoped tokens around. So no audience binding. Yeah.
So on the third bullet, the performance thing, is anyone here familiar with the concept of chunking as it applies to the Kubernetes API? It is effectively, you can do a list of some resource, and You can ask for it to be returned in some chunks instead of the entire list as once. Clayton added this feature because in Openshift, we had so many secrets from service accounts that if you did a list of all secrets across the cluster, you basically crashed Xkcd. So when you get back like 5 gigabytes of secrets data, you realize it doesn't work. And as a band-aid, we said, all right, well, we'll chunk it so at least it works. But in a future that hopefully not too far, we won't need to worry about that because we won't be storing them in Xkcd to begin with.
Yeah, so if in clusters with a very large number of namespaces and a very large number of service accounts, that data that we store in the CA cert and in the token itself add up to be like gigabytes. So what did we do about it? We created a new type of service account token. We don't really know what to call it. Some people call it the bound service account token. I want to just call it a service account token, but we haven't migrated everything over yet. The improvements we made are it has its own volume projection type, so it's not backed by a secret, which some people have rightfully criticized as not being a very secret, Kubernetes secrets. There's flexible verification of these tokens using the token review API. So like we mentioned earlier, there's audience binding. So you could get a token that's bound to the audience of Vault or the Istio Citadel CA component. And when Vault or Istio receives that token, they can issue a token review, specify what audience they identify as, and get back an authenticated user info. There's also, I don't know if we've actually added this to the KEP yet, but I think we are going to document that these are JOTs. So if in some situations the token review is not compatible with how these tokens need to be authenticated, we're actually going to document that these are JOTs, where we just merged a KEP to expose issuer discovery information about these tokens that allow non-interactive token validation. Again, they're never stored in Xkcd. And so one thing that makes secrets not very secret is that they are world rootable. So we fixed that, which has caused a number of issues that I have a slide on later. The other thing is secrets our support injection into environment variables, and that is not generally a very good idea because environment variables are broadly readable by other processes on the same machine. So we turned off that feature, so there's a chunk of like minute breaking changes that has made this new awesome service account token extremely difficult to roll out. So we have an alpha feature, and if you turn it on, your cluster probably breaks. But we are trying to figure out what it's going to take to roll this out. I think there's potentially features that we could add to Kubernetes, such as volume ownership. So instead of right now, all the projected files from projected volumes are owned by the root user. I think there's potentially a way that we could shown those to the user of the container, but that actually requires a substantial refactoring of how kubelets manage volumes, because volumes are currently shared between all containers in a pod, and containers can run as different users. That was one of the issues. The other issue is that all client libraries read the token once and never again, and these tokens now expire. So we retrofitted Client Go in 1.12, I think, to start reloading these tokens periodically. and we have filed a bunch of bugs against all the other client libraries, and they are slowly getting fixed. But that's also a great way that you could help out. And
I can't remember the exact specifics of what Jordan said, but you could, in theory, have metrics that are based on if you have a service account token that is one of these style that's being used for longer than an hour by a pod, because that innately tells you that that pod is not reloading tokens, right? So you could assign a lifetime to these tokens that is significantly greater, like, you can make it 10 years or whatever, so it's never gonna expire during the pod's lifetime. But if you see that pod not getting auto-refreshed, or not picking up the new auto-refreshed token, you know that pod's not reloading it, right? So having those types of metrics through our auth stack would make it much easier for you to migrate as a user of this feature.
Mm-hmm. Yeah, and I think there is another approach, which is to, what was that? Oh, okay, sorry. I think that there's another approach to this. There are really great improvements that these tokens make, but they're not useful if we can't roll them out. It is a potential solution that we concede on some of the hard lines that we were trying to take on these new tokens. So this is kind of a work in progress right now, and we don't have good answers yet. Do you have a question?
Yeah, it's slightly like, it's more about the lifecycle process for these than the tokens themselves. I think this like whisper distribution thing is really cool. Are there primitives that you're building for this that are useful for other types of secrets?
Yes. I think a good example is the project that Rita has been working on, the Data Labs secret, secret CSI driver. I think there's a really nifty integration with something like that, where a secret driver, such as the one that Cert Manager uses or the Data Labs one, could use a service account token to gain access to a system like Vault. So, or request a certificate from the Kubernetes Certificates API. So we want to use these tokens as a way of building integrations with systems that are better at handling secrets than Kubernetes is.
Yeah, I think we want to be careful not to reinvent Vault directly embedded inside of Kubernetes. We want to instead make the path of using Vault very clear and very sort of supported. Like I know, like when you start with Vault, it'll like use a service account token as like the foundation of it, and it's like, one of these long-lived, hard to revoke tokens, and it's not what we want. There's a question behind you, Mike.
Hi, I'm curious about, right now in our CI/CD system, we're connecting using the token from a service account that's scoped to RBAC roles. And I'm wondering, with expiring token, do you have any ideas on how you would manage like a connection? Will we need to have some kind of new client libraries that can do like renewal or something like that?
Do your applications run in the cluster or as pods?
Yes.
Yeah.
But this is basically for the CI/CD system to, well, we're deploying through GitOps, but if we need to examine the behavior of in-cluster resources, like query to make sure that everything spins up and we can hit it before we start running integration tests against the new pods.
Yeah. So right now, that lifetime is requested as part of the pod spec. There is like a soft max that can be set on the API server, such that if the user requests more than what an operator would allow, that the TTL gets pushed down. You could conceivably set that up to be a year or something and kind of maintain the old flows of create a service account, wait for the secret to be created, download that secret, and put it in your Jenkins script.
On the Jenkins, or like just CI or whatever, like is the CI, like the initial point, actually running in a pod? Like if it's running in a pod to then interact with external systems to run the CI system, like it could just be rereading like on disk the ever-changing token. But that
Yeah, I mean,
depends.
in this case, it's like we're using Azure DevOps, and it has a service connection in that given project. So as part of the pipeline, when it goes to deploy or query using like kubectl, it uses the service connection, which was based on a static secret that was bound to that connection. So I think long term we would rather have some kind of trust established, so you could renew those, but not that we like having a static token right now, but it seems like there's some tooling that still needs to be built in order for it to be fully functional.
Yeah, we are very aware that this is a pattern that a lot of people have depend on. See it a lot in CI, see it in like the GitHub configure CI pipeline, download a service account key, put it in the YAML, and send it away. So we're still trying to figure that out.
Question?
So I want to see if we have two pods, A and B, running on the same node. Is it possible for like pod A to somehow get the service account token of pod B?
Do you want this to happen, or are you asking from a security, like, okay. Yeah, so basically how it works is it's driven by the kubelet. It's fairly complicated, but kubelet uses its own authority, the kubelet user, to request a token for a pod before the pod starts. A pod can only gain access to tokens for the service account that it runs as. The token that is handed back by the Kubernetes API actually has a claim that it is bound to that pod, so it embeds the UID of the pod, embeds the UID of the service account, and embeds the UID of the namespace. And any deletion of any of those objects in the Kubernetes API invalidates that token, so any token reviews would no longer succeed. So it's the action of deleting the pod would revoke that token's access. Because it is driven by the kubelet, it has the same guarantees that of isolation that most other things have.
Yeah, so like if there's a privileged pod running on the same node, it can just find wherever the token is on disk and read it, but ideally you don't have that happening.
Yeah, Tim has a good talk on all that stuff, but I don't know. Would you add anything to that?
No, I think you covered it.
All right.
Maybe the one thing to add is if you have a privileged pod or any sort of attacker who's managed to escalate to running as root on the node, they have access to the union of all of the service accounts, and by extension, all of the permissions of all of the service accounts running on the node. So that's everything running in the pod, that's the kubelet, any daemon sets that you run, that's all part of the node's set of permissions.
And as a very simple example, like if you were running something like Cert Manager, anything that can list all secrets, right? You could list it, if you got access to that, you could list all secrets. That allows you to list the secrets for all of the other service accounts in the entire cluster. And if any one of them is given cluster admin, well, you've won.
And that's why we want to remove secrets from
Yes.
tokens from etcd. And so this is fairly complicated. There's some setup process. The kubelet is also responsible for periodically reissuing that token and making sure that it's up to date. However, this is all exposed via a volume projection, which is just a volume type. Really, all you have to think about is reading that token from disk and sending it to whoever wants to know who you are. Yeah, go ahead.
I was just wondering if the tokens on the server aren't stored in etcd, where are they going to be stored?
On TempFS, right next to the pod.
Yeah, so they're fully ephemeral. They're signed or they're created on the fly when you do a token request. If you were to do it manually, the kubelet is doing it on your behalf. And based on the metadata contained within them, they can be bound to other objects like pods, as has been mentioned, and sort of revoking them can be revoking the other objects. So you don't actually have to store them anymore. And ideally, they last for like an hour, so you don't need to revoke them at all.
So we create them in the API server and we forget about them. And we can re-verify them by using the signature of the token. So that each token has a payload, which says it's this pod, it's this service account, and then there's a signature associated with the token issuer's signing key.
Is that signing key in etcd?
That signing key is not in etcd, yeah. It's currently configured, only configurable on the command line, and it's just a file, but there is a KEP to allow it to be,
I knew Mike was going to plug that.
to move it off of the API server and put it in something like Cloud KMS or AWS KMS. Is that a thing?
Sorry, maybe I missed this, but is the idea that all the standard kube clients will transparently handle the rotation for you?
That is the hope. We are retrofitting clients, and it's just going to take a while for all those updates to happen. Yep. That's the goal.
I don't know if you mentioned it specifically, but you can tie a token not just to a pod that requests it from that flow, but you can request it to be bound to a secret, like a dummy secret, for the off-cluster CI case. That way you still have the revocability if you want to issue it for a super long lifetime.
And
Did you have a question? You just answered. Oh, okay. Never mind.
So we want to turn this on everywhere. There's a couple problems. API server needs a new flag. Client libraries all need to be retrofitted. Pod security policies, maybe
Again,
they're incompatible with the old secret version of service account tokens. And I guess pre-111, that's not really too big of an issue anymore because we're not running those big version SKUs. We don't support those big version SKUs. But we have some stuff to work through before we turn it on.
So as a question of trivia, can anyone tell me why the API server needs a new flag for this? Anyone? No, CJ, you don't count.
Why, Mo?
Because traditionally these secret-based service accounts, those were managed by the controller manager, so the signing key was only needed on the controller manager. Now that you have the token request API, the signing key, or a signing key, has to be present with the API server. So, there's another one?
Issuer.
Oh yeah, that thing.
So 2 new flags. And I think that if we can convince SIG architecture that it's okay to do this, it would be really nice to get this covered under conformance eventually. But we got to work through the problems first and get it to GA.
So how would this process differ from current out-of-cluster authentication into in-cluster that's using JWTs or other kind of signed tokens?
Specifically Kubernetes service account tokens. Is that what you're asking?
So like if you're a user authenticating to the server and you have JWTs set up, you have a signer and a authorizer already, would this just be only for internal, or would you be able to essentially have those be the same? So you could have an external thing signing both internal and external users?
Currently, the authentication plugins stack. So this one is specifically for in-cluster services. If we see a JOT that has a different issuer, like accounts.google.com, we won't actually enter this authentication plugin. So we check that issuer URL, see that it's the issuer URL matches our token issuer, and then enter that. So I don't think that they would conflict, but I would not recommend using this for more than just service identity within the cluster, although many people are.
If
so.
the external signing stuff merges, you could. I don't think it'd be a good idea.
Yeah, I definitely think about the security implications.
Same, but
Yeah.
the cluster being trusted to sign probably.
And there are things that are unsolved even with awesome tokens. They're forwardable. You send them in a bearer authorization header. That means that they can be replayed. This is mitigated by that audience field that we added. However, if you have a microservice architecture, you may be talking to 10 or 100 different services, and managing all tokens with least audience scope is a significant hassle. It won't scale. The other thing is, if you're sending tokens around, you have to authenticate the person who is receiving the token. And Kubernetes service account tokens do not solve server authentication. While I see these tokens as a great way to bootstrap higher level identity systems, such as like the Deus Labs example and the secret driver example and the cert manager example, I think that the direction for server-to-server authentication is in mutual TLS. So we want to make sure that we can support provisioning of higher level identity systems. I think that's where these tokens are valuable.
Is that the last slide?
Yep. Cool. Any questions? Please rate our session if you enjoyed it.
We have a question. We have a question on the right. And I think we are still got a few minutes. Okay.
I forget exactly what it was called, but there was a KEP about the API server verifying tokens, not from a file of public keys, but through some other kind of API.
I just talked to Mo about that, and I told him that I'm going to...
I don't believe this, Mike. I'm going to say you planted him in the audience.
Yeah, are you a plant? To merge that in December and have that be an alpha feature in 118. Yeah.
What is it?
External service account token signing.
Yeah. So similar to the KMS API, a gRPC API that offloads the signing of tokens to something else.
Yeah, and verification, yeah.
Second.
And verification? I can't remember.
Does it really matter if you have a public key?
Yeah, I can't remember. I don't think that we just.
Oh, well, yes, you asked public.
Yeah, we reload a key set from that currently a gRPC socket and do verification inside and signing externally. Cool. Any other questions?
Yeah, I'm thinking about admission webhooks now. Particularly, it seems like CRDs is like a lot of like there's conversion webhooks, mutating, validation, blah blah blah, and they require their own server certs. I'm wondering because it seems like the expectation is most of these webhooks are running on the cluster. Cool. I'm wondering, is there any way like maybe this could be streamlined where a webhook could be validated by the service account running it?
I think there's an issue about this too. Setting up like aggregated APIs and validating admission webhooks is way too hard. We should be able to provision certificates for server and client TLS to pods, is my opinion, and I think it would streamline and make make admission webhook configurations portable to be able to say use the cluster's root CA, don't embed that giant per cluster cert in there, and automatically provision a serving certificate for a webhook. We need those features for core infrastructure, and they're generally just useful. So I would really like to see progress on that in 2020 as we build out user stories for the certificates API. I think that'll be one of them.
We don't want to re-implement Istio in core Kubernetes though, so
yeah.
We'll have to figure out what the right scope for that is.
Yeah, I think we want stuff that strengthens core Kubernetes infrastructure, and then we want to build extension points. In this situation, I think it's okay to consume some of the certificate provisioning.
I think we're out of time, but we will be around if anyone wants to keep chatting about anything.
Thank you, everybody.
Thank you, guys.